Right. Good day, colleagues. Good day, grade 10s. My name is Impahama, subject advisor here in Mateo District. We are still continuing grade 10s with functions. The past weeks, we have covered the linear function. We also covered quadratic. Now we're going to look at hyperbolic function as well as exponential if times allows, right? Very important to keep on recalling the concept that we have learned because they build from one to another. Right, let us get started, not to waste time. Functions, grade 10, hyperbolic functions. Like I indicated that the straight line, we've also covered that. Parabola, we also covered that, which is also called quadratic function. Now today we're going to look at hyperbola as well as the exponential graph. Right. Very important here, like I indicated, that because we are laying the foundation, that we need to understand, we need to learn the shape of the graph, and we also need to learn the shift, especially the vertical shift on the graph. Those characteristics of each and every graph, they are very, very important here. Right. I want us to start first with this investigation. Know the standard form of the hyperbolic graph, hyperbolic function is y is equals to a divided by x plus q. That is the standard form, or that is a general equation for hyperbolic function. Now, let's look at this investigation. I know that, remember last time I indicated some of them I will run very quick on them, but you have enough time, sit down at your own time and then do it, take your time so that at least you can learn the behavior of each and every graph. Right now we have the investigation here, y is equals to 2 divided by x. Now we say complete the table using the substitution method. Now we have the values of x that you can substitute to replace x, and this is what you'll get. If x is minus 6, then you get minus 1 over 3. If it's a minus 4, then you get negative 1 over 2. There we are. But that 0 there, you cannot divide by 0. It's undefined, and we've got 2, 4, as well as 6. Those are selected values on the left-hand side of 0 as well as the right-hand side of the 0. Then your graph then will look like this one. Your graph will look like this one. At 0, it was so undefined. We couldn't get the y value. We couldn't get the y value there. Okay. Then that is the mother. We usually call them the mother graph. This is the mother graph. Y is equal to a divided by x. 2 divided by x. That is a mother graph. Okay. Right now, I would have many, but let me look at this one so that at least we can have a clear understanding of what is the effect of Q on the graph. Now, the investigation number 2 now talks to y is equals to 2 divided by x plus 3. What does the 3 does to the graph? We need to see that. Then we wanted to complete the table using the substitution. Please make sure that you use your calculator and please punch in the correct information. Then for minus 6, minus 4, minus 2, as well as for 2, 4, as well as 6. For 0, it's still undefined. And then this is a graph that we are getting. The red one represents 2 divided by x, y is equals to 2 divided by x. And then the green one represents y is equals to 2 divided by x plus 3. Now, when you look at this graph, you can tell here that something happened to the graph, right? Yes, I can hear some of you guys are saying, yes, it's like the graph shifted. But yes, I agree with you. Is the graph shifted up or down? The arrow says the graph shifted up. How many units? 3 units. Very, very important. Right now, let us try to make sure that we really do understand what we are talking about. Yes. I said that the red one is indicate the mother graph. The red one is indicate the mother graph. 2 divided by x. It's the mother graph of that. And then we sketch the graph. Then let me keep it red. Let me keep it red so that we don't confuse the two. Then here we are. This is the mother graph that we have. Now, you saw it on that side. Can you see? The graph moves, but the graph will never touch this line, and also the graph will never touch the y-axis. We'll talk about it later on. Right now, if I add 3 on it, then what's going to happen? That is 2 now divided by x, 2 divided by x plus 3. 2 divided by x plus 3. There we are, right? Okay, there is one, okay. There is one line that is missing there as well. Then you must include that line, and you need to use the different color now so that at least we don't confuse the two. Here it is. But when we check the first graph, we have this line that we said that the graph will never touch, right? That one is where f at x is equals to 0. Then we use the broken line for it. I will tell you the name of that line. Here it is. Look where the line is. The line lies exactly on the x-axis. You look at this line, that is where our x-axis are. Right now, the second one, which is supposed to be green, I will correct that. Supposed to be green. Then it's y is equals to 3. They must insert the new function here. Y is equals to 3. This is a person who must be green, and this one must be red. Yes, this one must be red, so that we're able to see what is happening. Thank you, thank you. Right, here we are. Thank you. Now, look at it too now. This is a picture that you saw on that slide. Now, the line y is equals to 0, the graph will never touch it. And also the line y is equals to 3, the graph will never touch it. But what happened is the shifting. The graph went 3 units up. 1, 2, 3. They are simply at the 0, but now it is at 3. It means the graph shifted 3 units up. If it was negative, then what do you think will happen? If it's negative, then if you have 2 divided by x, then we have minus 3 there. Divided by x, then we have minus 3. So what's going to happen? Let me take a different color now. I can take the black, navy, purple is fine. Then it's a solid line. Right, what do you think will happen? There's one line that I must show, so that at least we can now be able to make that conclusion. That will be a minus 3. Then the line must be like this one. Then here it is. Can you tell me what happened to the mother graph, the red one? What happened to that graph? Yes. Now, some of you guys are saying the graph shifted 3 units downwards. You are very correct. Look, for the mother graph, we've got y is equals to 0 here. But for this one now, we have y is equals to minus 3. Then it says the graph shifted 3 units downwards. Please keep that in mind. Very, very important. Now, the value of q here, remember we agreed to have, we have y is equals to f at x plus q. That is what we said in the general or the standard form for hyperbola. It's a divided by x plus q. That is what we are studying now in grade 10. Very important. This one, shift the graph, right? Shift the graph up or down. Let's keep that in mind. I will say up. If q is greater than 0, we agree the graph will go up. But if q is less than 0, then the graph will shift downwards. Please keep that in mind. The other thing that I would love you to look at grade 10 is that the A. What does the A does to the graph? Let's look at that. The effect of A on the graph. Can some of you tell me? Maybe you did some work while I'm still not there. What did you do? Yes. Now, let's look at it. What is it that we must do here? Let's look at it. That is the last one that must go. Right. Here it is. That is a mother graph. Now we've got the value of positive 2 there. That is 2. But now, if I make it now to be 7, then now it becomes now 7 divided by x. That is 7. 7 now divided by x. Let's see what's going to happen. Okay, I'll use the purple one. Look at it. Can you see now? This one of 2, it is very close to the axis, both y as well as x. It is very close. But now it's like when the value is more now, the graph is moving away from the axis. Let me verify this one. Let's have the last one where maybe we can have maybe 16. If you have 16 divided by x, and see what's going to happen to the graph. See what's going to happen to the graph, right? It should be the solid line. Okay, there we are. Can you see now? The more the values increases, and then the graph moves far away from what? From both axes. It moves far away from the y-axis. It is moving away from what? From the x-axis as well. Keep that in mind. Q, I said shift the graph up or down. But when it comes to the A, for now, let's neglect the negative, focus only if it is positive. Right now, if the values are less, the graph comes closer to the y and x-axis, but if the values are more, bigger, then 16, 17, 18, the graph now move away from both x and the y-axis. Please keep that in mind. Grade 10 is very, very important. Right, now I mentioned that the graph will never touch the red line, the x-axis as well as the y-axis. What is the reason for that? This one we called them the asymptotes. This one we called the asymptote. This asymptote is the line that the graph will approach, but it will never touch. It's a line that the graph will approach, but it will never touch. Then we call it the asymptote. Please keep that in mind. Okay. Right, now, this is the one that we can look into. Please, at your own time, try to sketch the following using the table. Remember, the one that I have up there was only on the positive. Let's look at minus 3. Minus 3 divided by x, what's going to happen now? Then it means now we need to identify now where the graph is. Look where it is now. This is asymptote. It is on this side. And yes, we did the trigonometry, fortunately for now. We know that this is the first quadrant this side is the second quadrant, the third and the fourth. If I were to use the quadrants, then the first arm is on the first quadrant and the second arm is on the third quadrant. Now, if it's positive, now we can check now if it's negative, what's going to happen. That one then is something that you can also investigate at your own time to say, if I have minus 2, if I have minus 5 divided by x, what's going to happen to the graph? What's going to happen to the graph? Then look now, the graph now is on another quadrant now. Quadrant 1, quadrant 2, now it's in 2 as well as what? 2 as well as 4. Now we can say the negative talks mainly to the reflection. Remember last time I spoke about the reflection about the x-axis, reflection about the y-axis. Now this is a reflection about this is a reflection about the x-axis, because now this part of the Mara graph now shifted now to reflected now to the fourth quadrant, and this one reflected now, this one on the third reflected now to the second quadrant. Okay, right, now let us continue now. Please just carry on. Try to do number 1, where y is equals to minus 3 over x. Check the behavior of the graph. Y is equals to minus 1 divided by x minus 2. Check the behavior of the graph. I can see now the graph is going to shift, but which direction? Then we can tell about that. And then minus 2 divided by x plus 2. The same apply on this one. There will be a vertical shift, but what's important is you must be able to see which direction are they talking about here. Very, very important. Okay, now when we come now to conclude the investigation, now we can now say, based on what we have observed, the value of a in the equation y is equals to a divided by x plus q. If for now we ignore the negative sign, right, let's work with the positive. Now, determines the vertical stretch of the branches of the hyperbola from the x-axis. Very, very important. And then the larger the value of a, the further the stretch away from the axis. Like I indicated, the larger the value of a, the more a becomes bigger, then the graph move far away from the x-axis. Only both y as well as x. Right, what about the negative sign? We have seen now the negative sign will cause a reflection in the x-axis, like it did with the other graphs as well. A quadratic, the negative sign will cause a reflection in the x-axis. If it was in the first quadrant, then it will move now where? It will move now in the fourth quadrant. Very, very important. That is the effect of a on the graph. Right, the value of q in the equation. the value of q in the equation y is equals to a divided by x plus q determines the shift of the graph. Very important. You saw when it was a plus, the graph shifted 3 units up because it was plus 3. Then when it is a minus 3, then the graph will shift 3 units downwards. There we have. Now determine the shift of the graph of y is equals to a over x, which is the mother graph, up or down, depending if q is positive or q is negative. And it also, very important, I mentioned the issue of the asymptote. The same value of q, it also represents the horizontal asymptote of the graph. The value of q is also represent the horizontal asymptote of the graph. I mentioned that this graph has asymptote, but now I need to understand how many asymptotes do I have. The hyperbolic functions has 2 asymptotes. The graph will not touch the x-axis. The graph will not touch the y-axis. Now I'm talking now to the mother graph now. Right, now let's take note now and look at this one. Now, for the hyperbolic function with the general equation y is equals to a divided by x plus q, with the understanding of what is q, the effect of q on the graph and the effect of a on the graph. Right, now, first of all, we need to remember the shape. I said very, very important to know the shape of the graph. Right, if a is greater than 0, if a is positive, then the arm then will be in the first quadrant and the third quadrant. Keep that in mind so that at least you can be able to see if your sketch is correct or wrong. Right, if a is less than 0, then it will be in quadrants 2 as well as 4, right? That is the one that we're talking about. This then will be a reflection about what? It will be a reflection about the x-axis, because it was in the first, now it will be in the fourth. It was in the third, now it will go to the second. Okay, right, now we said q represented the horizontal asymptote, as well as the q shift the graph up or down. It's also represented the horizontal asymptote. Very, very important. Now, always when you're asked about the equation of asymptote, look at what is the value of q. If q is a minus 3, therefore the equations of the horizontal asymptote is y is equals to minus 3. If it's a positive 5, then it's y is equals to a positive 5. Right, very important. We spoke about the domain and the range last time, whereby we said now when you talk to the domain, we talk to the values of y that form part of the graph when you read from the left to the right. Okay, right here, the domain, x element of real is a real that does not appear there. X is element of real. It means all the values from negative infinity to positive infinity. Right, from negative infinity to positive infinity. But now we said earlier on, the graph will never touch this line. And what is the equation of this line? This line is where x is equals to 0. So the graph will never touch x is equals to 0. That is why you need to indicate that the domain is x element, negative infinity to positive infinity. It means all the values of x, but not where x is equals to 0. Why that? Because that is where the asymptote is. We're going to talk about that so that at least we can understand. Right. Then the other one then will be the range. Then what is the range of the graph? Y element of real. It means all the values of y from negative infinity to positive infinity. It means we start there at the bottom, then we go up. Then also not forgetting that y cannot be q. Right. Y cannot be q. Okay, here we are, y element, negative infinity, positive infinity, y cannot be q. Grade 10s, you use one of the two. You can go with y's element of real, y cannot be q, or you can use y element, negative infinity to positive infinity, then y cannot be q. That is what you can use when you determine the domain of the function as well as the range. Okay. Right, the other one then is axis of symmetry. Yes, we spoke about it when we were doing quadratic. Now, they can call it axis of symmetry or the line of symmetry. Very important. For this one, we have y is equals to x plus q. For you specifically, grade 10, I will say y is equals to x plus q, right? And then we can also have y is equals to minus x plus, y is equals to minus x plus q. Very important. Maybe we need to see what is it that we are talking about when we talk to y is equals to x plus q, and then y is equals to minus x plus q. Now, before I can write it down, let me have it on the sketch here so that at least we can understand and see what is it that the line is doing to the graph. Okay, now we're going to look at it now. We're going to look at it very, very now. Here we are. Right now, the line that we are talking about at the moment then is y is equals to x. Y is equals to x. And q is 0 here, right? Q is 0. Here it is that line, right? It is that line. Here it is. Then the other one also, there are two of them. Then the other one will then be y is equals to minus x. Y is equals to minus x. Here it is. So what is the value of q here? The value of q here, it's a 0. If I'm asked to determine the equation, I always look at q, especially now in grade 10. If you can see what is your q, then we've got the equation of the axis of symmetry or line of symmetry. This one must pass at this point where now the vertical asymptote and horizontal asymptote touch each other. But why will it always be a q? Because of what? This line will always be 0. X will always be x is equals to 0. That will be the vertical asymptote. Please keep that in mind. Very important. So now, if you sketch the graph, then that graph is shifted up to what? To positive 3. Then if it is in this quadrant, then we'll have it there, and we'll also have it this side. Okay? Not forgetting that the graph will not touch the asymptote. No, the graph will not touch the asymptote. This is the x, this is the y. Okay, the line that I'm talking about is this line that will go through here and will cut the graph into two. So it means when I reflect or the mirror image, no, so this will be the mirror image of this side. So it means when I fold it on this side, it will lie exactly on top of this one on the other side. So it does the same thing on this one. Remember on parabola, no, I said exactly the same thing, that if I move this one on the other side, it will sleep exactly on top of it. Please, that is that line. If it's increasing because it's a straight line, then x is always positive, then plus q. But if it is decreasing, if it goes down like that, then we'll have y is equals to minus x plus, y is equals to minus x plus q. Keep those in mind. Very important. But at our grade 10 now, we only focus on the value of q. Okay, right. Those are the notes that you must remember every time when you are dealing with a hyperbolic function. That is, the general equation is y is equals to a divided by x plus q. And then if a is positive, greater than 0, it will be in the first quadrant and the third quadrant. If it is less than 0, then it will be in the second quadrant and the fourth quadrant. Then what is q? Q represented the vertical shift. Can go up, we can go down, but it's also represented the horizontal asymptote. Then the domain and the range, I said, is all the values of x, but not the asymptote. The graph will never touch the asymptote. The same applies with the range, all the values of y, but not the asymptote. Okay, right. Let's take an example and work through this example and to see exactly what is it that we are dealing with here. Okay, right. We are given f at x is equals to 2 divided by x minus 3. Okay, this is what we have. We have f at x is equals to 2 divided by x minus 3. Good. Now, let's see now what's going to happen now. Right. When we were doing the investigation, we used point by point. It means we had a table. We used a table. That is what we encourage you now, so that at least you can have very clear understanding, or you can see clearly how does the shape of the graph look like. But once you have mastered that, then you can now go to the dual intercept method, where now you determine the x-intercept as well as the y-intercept. But the first thing that I need here, let's follow the question. It's fine. The question now says 1.1, write down the equations of the asymptotes of f. Write down the equations of the asymptotes of f. Right. How many do we have? We have 2 asymptotes. It's the vertical asymptote as well as the horizontal asymptote. Please, grade 10, follow the question. If they say write down the equation of the asymptote, it means they want x is equals to something or y is equals to something. But if they just get it, what is the vertical asymptote? It's a 5. What is horizontal asymptote? It's 6. Then it's but the equation is either you have x or you have y. So in response to question 1, right, we said the Q represented the horizontal asymptote, then it means y is equals to minus 3, because this is the value of Q. We take it with the sign. Okay, right, the other one is x is equals to 0. For now in grade 10, this will always be the case. X will always be equals to 0 because of what? Remember, when we substituted 0 here, we had 2 divided by 0 undefined. So that is the reason why this will always be 0. Please keep it in mind. It means for your grade 10, your focus is in Q, but the vertical asymptote is always at a 0. Right, the next question is write down the domain as well as the range of f. Write down the domain as well as the range of f. Right, we spoke about the domain as well as the range. We spoke about the two. Right, now, what is the range and what is the domain of the function? Very important. We said the domains are the values of what? The values of x that form part of the graph. Then what we are having here will then be, I said number 1, you can have x element of real, and then we agreed that x cannot be the asymptote, right? What is asymptote here? Asymptote is 0. So this one is the one that we are talking about. X cannot be 0. Thank you. Or if you don't want to use x element of real, I said you can also say x element, then you have negative infinity to positive infinity, right? X element, negative infinity, positive infinity, but x cannot be 0. Let us not forget that one. It is very, very important. Okay. Then you can also use set builder notation. Then we have different ones that we can use. Okay, right, that is one. This one is where we are talking now today, to the domain of the function. Now, let's look at the range. How do we determine the range of the function? Then the range we are talking to the y values. Then we have y element of real, all values of y. Then y cannot be the asymptote to the q. Then what is the value of q now? Q is equals to minus 3. Very, very important. Y element of real, y cannot be minus 3. Then if you don't write this one, keep in mind that you can also have y element. We start from negative infinity to positive infinity. But not forgetting that the graph will never ever touch the asymptote, which is in this case is a minus 3. Okay, right. Now the next question now says 1.3, calculate the x-intercept of the graph of f. Calculate the x-intercept of the graph of f. Let's see if we can get that. Let's see if we can calculate the x-intercept of the graph of f. Right, that is 1.3. The x-intercept. Now, what you remember from the other lessons that we did, that especially for x and the y-intercept, yes, for x-intercept now we said we must let y to be 0. So it means we have y is equals to 2 divided by x minus 3. That's what we are having. But now since we are looking for the x-intercept, y must be 0. So we let y to be 0, then we have 2 divided by x minus 3. So what do we do next? We move 3 on the other side. It's a minus 3 here. So it means you're going to add 3 on both sides. If you add 3 here, and then also add 3 this side, so what do we get? We're going to get positive 3 is equals to 2 divided by x, because minus 3 plus 3 is equals to 0. Good. And then this is over 1. What do you see? We can now do cross multiplication. We take x times 3, will be 3x equals to 2 times 1, then will be 2. Then from there, divide by 3. Therefore, x is equals to 2 divided by 3. Very, very important. That is how we determine the x-intercept. Okay, right. Now, I think the next question now will say now we need now to draw a neat sketch of f showing clearly all intercept with the axis and the asymptotes. Yes. Now, very important at our level now in grade 10 to say, when we sketch the graph, we need to make sure that you do it the right way. Please, yes, sometimes we prefer to be fast. I don't know why are we so in hurry. Why are you so in hurry? This is what you do. You use your ruler, and then the scale must be correct so that at least you can see what is happening on your graph. Right? Right now we are done with the x-axis. Now I'm on the y-axis now. This is the y-axis, and I'm making sure that the scale is the same throughout. Okay, this is the y-axis, this is the x-axis. Now I'm going now to plot the graph now. Right. First of all, we need to start with the asymptotes first. That is where we're going to start when you sketch the graph. I must show now the vertical asymptote always 0. It means that asymptote is on the x-axis. Then from there, horizontal asymptote is y is equals to minus 3. Let me show minus 3. This is minus 1. This is minus 2, minus 3, minus 4, minus 5, minus 6. And I have 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5, 6. Then minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Right? Now, where is minus 3? Here is a minus 3. Then I'm going to show that minus 3 here. Then we now indicate minus 3. So we represent the asymptote with a dotted line. There we are. It's a minus 3. It's a minus 3 there. That is what? That is the equations of the asymptote. Okay. Then from there, what we need now is to have x-intercept. X-intercept is at 2 divided by 3. What is 2 divided by 3? Okay. We can check that one. It's not a problem. You can use the calculator to check that one. Right. Let's check what is 2 divided by 3 very quick. That is, we have 2. Then we must divide it by what? We must divide it by 3. Then what do we get? Yes, most of you are saying 0.67. Can you see that? Yes, that is 0.67. We are fine with that. So let's write it down. So it's 0.67, the positive one, right? Yes. It means it is going to be on this next one. That is 0.67. And then from there we can show the graph. Free hands, please do not use a ruler. No, free hands, then the graph then will go this way. If you are unsure of what you are going to do, then you can use the points. You can use the point. You substitute minus 1, you substitute minus 2, you substitute minus 3, minus 4, minus 5. Then it will give you a clear indication of what you must do. Okay. Right. Let's now see. I want now this side. Remember now we said if A is greater than 0, the type of shape that you are looking for is this one. It will be in the first quadrant as well as the third quadrant. Now, what must I do now? I need now to have this side here. How do I get that one? Very important to take only 2 points. You can take 2, 3. That is your choice on the left hand side of that y-axis. Now, let's take what? Let's take minus 2 and then substitute it in. Let's take minus 2 and then substitute it in. Now we have minus 2, we have 2, what is the equation? We have 2 divided by, let me have the fraction. We have now 2 divided by minus 1, right? Then we also have minus 3. That is the equation. Then what do we get? We get minus 5. So you're going to go to say when x is minus 1, then y will be minus 5. Then we indicate that minus 5 here. Where the 2 meet, very important, x is minus 1, then y will then be minus 5. 1, 2, 3, 4, 5. Here it is. That is the point here. And then now we can take another one. The other one is what? Then the other one will then be minus 2. If I take 2 divided by minus 2, then minus 3. What are we getting there? Then the answer is what? Minus 4. So minus 2 goes with minus 4. Then I show that one there, indicate. So this here it is. Right. The 2 points are enough, but let me take the last one. Maybe I can take 4. let me take minus 4. So I have now 2 divide by, okay, cancel. 2 divided by minus 4, then minus 3. What do we have? Then we have minus 7 over 3, which is negative 3.5. Negative 3.5, negative 3.5 goes with minus 4. Here we are, negative 3.5, it's somewhere here. So you see it's very close to the line. I think the 3 points are enough. I still remember that the graph is not supposed to touch the y-axis, so it go like this one. There we are. Then we have the shape. So now I understand. Now this is a hyperbola where the arms are in the first quadrant as well as the third quadrant. Very important. We said the domain of the function is all the values. When I move and when I determine the domain, I said the values of x that form part of the graph. From negative infinity, I move, I still have that, I still have that. I move, I move, I move. But when I get here, I remember, oh, but the graph does not touch this line. What is this line? It's asymptote. That is why we said x cannot be 0. And then you move to another side as well. You move, you move, you move, you move up until you get to positive infinity. That is the domain. The only point that does not form part of the graph is where x is equals to 0. Right, now the range, you start from the lower here on the negative side, from negative infinity. Then we still have the graph there up until here. When we get to this one, you realize, but the graph is not passing this line. It's not even in touching the line. Then this is the one that we said y cannot be minus 3. But above that, going to positive infinity, then the graph does touch the values of y do form part of the graph. Very important. Please make sure that you have an understanding of that. Okay, right now 1.5 now says determine the equation of the axis of symmetry that has a positive gradient. Determine the equation of the axis of symmetry that has a positive gradient. Now it is taking us back now to the linear. You remember we started with the linear. How do I know that the gradient is positive? Right, I think we spoke about 4 lines. We spoke about the 4 lines. The first one is this one. Then we said, how is the gradient of that line? The second one is this one. We spoke about it. And then the third line will be the horizontal. And the fourth one then will be this one. Okay, then we said, what is the gradient of this line? We said the gradient here is positive. M is greater than 0, and also it says now the line is increasing. Right, what about this one? The gradient is negative. Gradient is less than 0. Why? Because the line is decreasing. This one, the gradient is 0. Very important. And this is undefined. We don't have gradient for this line. Now, the line that they want is the one with a positive gradient. It means it's for this one. Now, how does the line go? Remember I said that line then will go through this point. It's a line like this one here that I'm drawing. Then this is the line y is equals to x plus q. The gradient of the line is a positive. Y is equals to x plus q. Very, very important. Very important. Now, we need to determine the equation of that line. How do we determine the equation? That is 5.5. Now we remember the equation is y is equals to be specific, we take the one with a positive gradient. It's a positive 1 plus q. Then what is the value of q? Q is equals to minus 3. Therefore, then we have y is equals to x minus 3. That is the equation. Y is equals to x minus 3. If I know what is the value of q, then I've got the equation of the axis of symmetry. Very, very important. Let's keep that in mind. If it was 0, then it would have just been y is equals to x. Now it is minus 3, y is equals to x minus 3. Okay. But if I would also to calculate the one with a negative gradient, then we'll have y is equals to minus x plus q. Then the line then will go in this direction. Can you see that? The line then will go in this direction. Now, can you see now the graph is decreasing? That is why we see the gradient is negative. Then what do? You identify the value of q, which is minus 3. Therefore, the equation is y is equals to minus x minus 3. That is that. Then we have it. Very, very important. Make sure that we do understand what we are doing. Okay. This is the equation. Y is equals to minus x minus 3. Yes. And then Okay, that was the last question on this one. Please create tens. Practice as many as possible. Practice as many as possible. Make sure that you understand. Remember, I said here you are just forming the basics of what? Of the next grade, which is grade 11. Now here we are only moving vertical. We are shifting the graph up or down. So next year we'll talk a different story. Okay. Right. Now let's look at the next part now. The next part now will then be, I said earlier on, the objective of this lesson. The objective of the lesson is by the end of the presentations here on functions, we must make sure that we know how to sketch the functions. That is number one. Number two, must be able to determine the equation of the function. And then number three, we must be able to interpret, read the information on functions. That is, those are the objective of the presentation. So by the end of the presentation, you must be able to do the three. Right. On this one now, we want to find the equation. We want to find the equation of the functions given. So we can talk to the first one. Number one, we have just a point on it. The coordinates of that point is a -2 and minus 6. Okay. Let's see what must happen. We have something like this one. This is the y, this is the x, very, very important, and also have that side there. This is the side that we are having. Right now, we know that the graph itself is telling that this is a hyperbolic function with the general form y is equals to a divided by x plus q. Right. Now, the first thing that we need to do is to identify what is the value of q. From here, we can see now q is equals to 0. Is that correct? Q is a horizontal asymptote. Q is a horizontal asymptote, is equals to 0. Therefore, we have y is equals to a over x plus 0. Then plus 0, I write or I don't write. Then it's the same thing. Right. Then after this now, the challenge is the value of a. How do I get the value of a? We have a point. Then it means you're going to substitute that point. What are the coordinates of the point? It's -2, -6. We substitute it in. Y is a -6. A divided by x is a -2. Then this is over 1. And then from there, then cross multiply. Cross multiplication. Then -2 -6. Then will give us what? Positive 12. A times that. Then it will give us what? A. Therefore, the value of a there is equals to 12. Then what is the equation? Therefore, y is equals to 12 divided by x. Do you have it? Yes. The first thing that you do, you identify what is a q from the graph. Then after that, now we have seen the q. Then from there, now you can substitute now a point from the graph. Right. Now, the second one, if we are to do the second one, just look at it very quick, guys. I think you must be done in about 60 seconds. Just look at it and very quick, 60 seconds. You must have started now. You just only need to determine the equation. You have only 60 seconds, which has already started. Work on it very quick. Right. Let me see what is it that you are having. Yes, some of you guys, you started very, very well, and I'm so impressed to see that, you know what, we are really following. Okay, right, where do we start? Yes, you recall that, we need to recall the general form. It's a divided by x plus q. Okay, I can see most of you started this one. Then from there, you identify what is the value of q. What is the value of q? Q is equals to 3, right? Q is equals to 3. Then here we are. Y is equals to a divided by x plus q. That is the general form or the standard form of the hyperbolic function. Then the value of q there, q is equals to 3. And then from there, we substitute it in. Y is equals to a divided by x plus 3. Then we are happy about it. Now, once you are happy, then the only problem that you are having is the value of a, right? Yes, I can see some of you, the answer that we have there. Okay, but let's see how did you got those answers. Okay, then what do we do now? We need now to substitute the point 1 minus 2. This is the point that we're going to substitute. Then this is the x, this is the y. So the y there, I replace it with -2 is equals to a divided by x is 1, then plus 3. Then what do? I minus 3 on both sides, minus 3. Therefore, we are going to have minus 5 is equals to a. What is a divided by 1? It's a. Therefore, the value of a there is minus 5. Then I can now write the equation y is equals to minus 5, replace a by minus 5 divided by x, and then the q there is, 3. Yeah, look at the smile that you guys are giving. Yes, it says now you are really following. Then you've got the same answer as mine, y is equals to minus 5 divided by x plus 3. Okay, right. This one very interesting as well. Very interesting. We have the graph there. When I read the graph, it's like we are given the axis of symmetry. Y is equals to x minus 3. Can you see that? Yes. Now, what is it that we don't have? We don't have the asymptote. We don't know what is horizontal asymptote. Are you sure we don't have? Okay, let's look at it. Do you want to try it first, grade 10s? Okay, I can see some of you guys have already started your 60 seconds. Very quick. Right. Let's see what is it that you have. Let's see. This is a graph that we're determining the equation for. We are given the point 1, minus 8, and then we also have what? The axis of symmetry, y is equals to x minus 3. Then what do we do here? And what we are going to do is to remember that we have y is equals to a divided by x plus q, right? That is the first thing that you're going to do. And then from there, we identify the horizontal asymptote. Do we have it? Not indicated on the graph, but I remember, the axis of symmetry. When I determine the axis of symmetry, I have y is equals to x plus q. Then we said the value of q there will represent the asymptote. Okay, then what is q here? Q is a minus 3. Therefore, I can read it from here to say, therefore, now this graph here will pass at this point whereby y is equals to minus 3. So the q is equals to negative 3. Then I can now substitute it to y is equals to a divided by x minus 3. Then I am fine. Then from here, what must happen? I must now find the value of a. Then I will go into substitute the point. What are the coordinates of the point? Minus 1, minus 8. Therefore, we've got minus 8 is equals to a divided by minus 1, minus 3. Right. Then what do I do now? Then from here, I add 3 on both sides. Minus 3 plus 3 will be 0. And then minus 8 plus 3 then will give me what? Will give me minus 5 is equals to a divided by negative 1. So then from there, it means what is a divided by negative 1? It's a negative a. Then this will be negative 5. Then I can divide by negative 1, divide by negative 1. Therefore, what do we have in here? We have a is equals to positive 5. Very important, because the shapes tell you that a here is greater than 0. That is why it's so important that always look at the shape. It will tell you a greater than 0 or a is less than 0. Thereafter, then substitute it back. Then you have y is equals to what? Y is equals to 5 divided by x minus what? Minus 3. That is your equation. Please remember that. That is your equation. Is it fine? Yes. Please, grade 10, make sure that you practice. We always say practice makes perfect. Okay. The last one has combination now. The last one is combination of the interpretation as well. The inequality sign now are there. Remember, we did it when we were doing what? When we were doing the equations. Now 6.2 says the sketch below show the graphs of f at x is equals to k divided by x plus w and g at x is equals to minus x minus 1. Now look at that. We are used to a and q. Can you see now we can use any variable there? Then we've got k instead of a, then we've w instead of what? Instead of q. Okay, the graph G is an axis of symmetry of G. Then you can see now this is the axis of symmetry, and it is the decreasing one, right? It is the decreasing one. Then the graph of f and g intersect at point P and G. Let's check. We did Smartinger's equations. Now, if the two graphs intersect each other, at this point they are equal. Most of the time we say we equate the two. We equate the two and then we solve them simultaneously. Okay, then the graph of f, this is the one that I spoke about. Thank you. Right, the first question says, write down the value of q. What is q? Write down the value of q. What is q? That is 6.2.1. What is q? Write down the value of q. W. Then W here, it is our q. Ne? Then it means W is equals to, because the axis of symmetry is y is equals to minus x minus 1. Then the W then will be minus 1, because this is our q. Keep that in mind, right? Yes, look at the axis of symmetry. We've got minus x minus 1. Therefore, W then will be minus 1. Right. The point minus 27 lies on F. Calculate the value of K for 2 marks. Now, it means now we need to determine the value of K. What do we do now? What do we do? We have the equation. F at x represents the y is equals to K divided by x. We know what is W now. We substitute it, minus 1. Right? Yes. We have y is equals to K divided by x minus 1. That minus 1 represents the W. Then we need to determine the value of K. There is a point on the graph. There is a point on the graph. Then what is that point? Then is a point. Then we're going to substitute the point. X is minus 2 and y is what? Y is 7, because we are told that the point lies on the graph. Very important to use the point that is on the graph. So this is x, this is y. So we have 7 is equals to K divided by x. Now we replace it, minus 2 minus 1. Right, what do we do now? We add 1 on both sides, we take it on the other side. The sign must change. So minus 1 plus 1 is 0. So then 7 plus 1, then it's going to be what? It's going to be 8. So equals to K divided by minus 2. So what must happen now? This is over 1 cross multiplication. K times 1 is K is equals to minus 2 times that will be 16. The value of K there is equals to 16. Okay. Interesting question is 6.2.3. I really wanted to see how you are going to attend that question for 4 marks. I'm really interested on that, but at your own time, please make sure that you go through it. I'm going to do with you because of time, but please make sure that you give yourself time to make sure that you go through it. Right now, they say calculate the x-coordinate of the point P and Q. What is happening at the 2 points? That is where the two graphs intersect. They cut each other at that point. So which graph are we talking about? We are talking about the graph of F, which is what? Which is y is equals to K, not K, but I must replace that. Y is equals to negative 16 divided by x minus 1, right? And which one? Y is equals to minus x, man. The two graphs, they intersected at that point. So I said earlier on, where the two intersect, then it means they are equal. Then it means we are going to take minus 16 over x minus 1. We equate it to minus x minus 1. Then you solve them together because both is y and y, right? When you're doing simultaneous equation, then we'll say you substitute x by what? I'll substitute y by this one. You replace x on both sides because the graphs are equal at that point. Okay, then from there, take 1 on that side. Minus 16 over x is equals to minus x minus 1 plus 1, right? And thereafter, what do you have? Then I'm going to get now a minus 16 divided by x is equals to minus x, because minus 1 plus 1 is a 0. So this is over 1. Cross multiplication, minus x times x will give me minus x squared. And then this will be equals to minus what? It's equals to minus 16. Because that is 1 times that. And then from there, I can divide both sides by minus 1, divide by minus 1, divide by minus 1. Therefore, x squared is equals to 16. Then what do? The method that I really don't enjoy, but I have to do it, is to apply the square root on both sides. Then what is the square root of x squared? Then it's x equals to the square root of 16 is 4. I can hear most of you are saying 4. That is the reason why I don't use this one. You know why? Because I'm just saying 4. You forget to say it must be plus or minus 4. You don't say that one. You just leave it at what? You just leave it at 4, then you think you're done. No. x squared, now you know we've got the linear, we've got the quadratic. Quadratic, we must have at most two solutions. That is why we give plus or minus. We've got two values of x that can give us 16. It's when x is 4, 4 squared is 16, minus 4 all squared is 16 as well. Those are the two values. Then the question was that determine only the values of x. So others I can see most of you said instead of applying the square root, you just said, okay, this is x squared minus x squared is equals to minus 16. You said, let me take x on the other side so that this one is a 0 because that is how we solve the quadratic. One side must be 0. Then we get x squared minus 16. Then after that we factorize. Then we've got this one, this difference of 2 squares. X times x, factors of 16, it's a 4 times 4. The other one positive, the other one negative. Therefore, you remember that x plus 4 is equals to 0, or x minus 4 is equals to 0. Therefore, x is equals to minus 4, or x is equals to 4. These are the two answers that we are talking about. Okay. Right, the last question here is write down the values of x. Write down the values of x for which minus 16 divided by x is greater than minus x. Do you see where does this one comes from? Yes, I can clearly see what is happening. This one comes from here. Minus 16 divided by x is greater than minus x. It means that is where graph of f is greater than the graph of g. I must write it down. That is where the graph of f is greater than the graph of g. Okay, let me just indicate it here. That is where the graph of f at x is greater than the graph of what? The graph of g at x. Now, let's look at it on the graph, okay? Let's look at it on the graph. So, this is the f. Here, f is below g. Can you see that? Here, f is below g, but we want where f is greater than g, right? So, we go up to this point here. What is the x at this point? X at this point is a minus 4, right? X at this point is minus. Then it means it is from minus 4 up until where? Up until positive 4. Okay? Yes, I agree with you. But now, there is something. Remember now. But x cannot be what? X cannot be 0. Keep that in mind. So, then it means it will be where x is in an element. Then you can just say from minus 4 to 0. No, minus 4 to 0. Then you can also say it's where x is also element what? Where x is also 0 to positive 4. That is the 2. Then you can use or there. Very, very important. There we are. We said f at x must be greater than g at x. So these are the values from negative 4 to 0. And then also from 4 to 0. That is how we write it. Or one can just say x element, negative 4 to what? To 4. But not forgetting that x cannot be 0. It's all those values. It's all those values. Let me verify something. Okay. No, it's not all. It's from 4 to 0, correct? From 4 to 0. From 4 to 0 or 4 to infinity. 4 to infinity. Don't have enough space. I will write it this side. It's x element, negative 4 to 0. Then or where x is an element. Look at the graph. We made a mistake there. Look at the graph. Look at the graph. Here the graph is below. Ne? The graph of f is below. We want it where it's above. There we are. So it means where x is element from 4 to positive infinity. Please, let us make sure that we look at that. We almost make a very big mistake, but we managed to correct that. Now, where the graph is above, the graph of f is above the graph of what? The graph of g. Very, very important. Please, grade 10, please make sure that you revise. This is the third function that we're doing. Then we are left with the exponential functions. Then after that, we consolidate so to make sure that we understand. I said this is a very, very critical topic. Make sure that you understand all the concepts that we spoke about. Then once you have done that, then I'm telling you that you are going to enjoy functions going to the next grade. Now, with those words, please make sure that you practice the notes that I gave, the shape, the domain, the the asymptotes as well as the line axis of symmetry. Make sure that you know that those one, they are only relevant to one function, which is what? Which is hyperbole.